Today's video will demonstrate how to implement the heap sort. Hello, I'm James Helfrich. The heap is the underlying data structure for the priority queue, but it also has another unusual application. We can create a sort from it, and we call this sort the heap sort. The heap sort works as follows. First, take an array of elements, we'll put them into a heap, and then from the heap, we'll extract them, the highest element first, and the next highest, and so on, until we have the array again. The algorithm follows three parts. The first part is the sort. And the sort is going to put everything in a heap and then extract the elements one at a time with something we'll call extract. How do we put things in a heap? Well, we do a process we call Heapify. And Heapify is going to put everything into an array. And then we're going to call percolate down on the highest index element that has a child, then the second highest index that has a child, and so on, all the way until we find index 1, which is the root of my heap. When I'm finished, then every element will be in the heap order. When I'm finished, I'm going to extract the elements. And I'll do this by taking the topmost element, swapping with the bottommost element, and then decreasing the size of my heap by 1, and I call percolate down. I will continue and continue and continue until finally every element is taken out of the heap. To demonstrate how this works, I'll start with an array of 8 elements. So I have 8 elements, index 0 through 7. But remember, heaps have a different index scheme. They go from 1 to 8. We do this so we can easily find the child element by multiplying by 2 and the root element by dividing the index by 2. So slot 1 corresponds to level 1 in my tree. Slot 2 and 3 correspond to level 2 in my tree. 4 through 7 are level 3, and there's only one element at level 4. And so the binary tree representation of this heap is as follows. Both the array and the binary tree representation are equivalent. So how are we going to start? We're going to find the first index that has at least one child, and that'll be index 4 with the value 32. And its child is 50, which is index 8. Now, since 50 is greater than 32, I will swap those. Now we'll find the next index will be index 3. Index 3 is value 10. Is 10 greater than its 2 children? Well, no, because index 6, or value 95, is actually greater than 10, so I will swap those. Now we'll look at index 2, and 72 is greater than 50 or 18, so I do nothing. Then I say index 1, which is my root, looks like 95 is bigger. Okay, now everything is a heap. The next thing I need to do is take the highest element, which is the root, and swap it with the bottom element. So I'm going to take 95 and 32 and swap them. I'm going to remove 95 from my heap, and I'll set 95 aside as the sorted part of the array. Okay, now my root is not necessarily in heap mode. Let's take a look here. We're going to call percolate down on index 1. It looks like 72 is bigger, so we'll swap it. Now we'll call percolate down on 32, which is index 2, and looks like 50 is bigger, so we'll swap it. Now we're in heap mode again. Okay, so I need to swap the index 1 with my highest index item, which is index 7. So I'll swap those two, remove 72 from my heap. So 72 comes off the end of the array and goes into the sorted side of the array. Now I'm no longer sure that my root is in heap mode, so I'm going to call percolate on it. And it looks like 50 needs to be swapped with 25, and then it looks like 32 needs to be swapped with 25. All right, now we're in a heap again. So when we're in a heap again, then we pop off the highest element by swapping index 1 with, in this case, index 6. So I'm going to swap them. Then I'm going to remove index 6 and then put it onto the end of my sorted array. Now I have to call percolate down on the root again, and looks like 32 is bigger than 10, and looks like 25 is bigger than 10. And now we're in a heap mode again. So I'll swap the root with the highest index item, drop it off the end of my heap, drop it off the end of the array, and put it into the sorted side. Now I got to call percolate down on the root again. It looks like 31 is bigger. All right, now I'm going to swap again the root item with the highest index item, remove the highest index item from the heap, which means take it off the end of the array and put it to the sorted side of the array. Now I have to call Heapify once again on my root, which is going to put 25 there. Now I'll swap 25 and 18. 25 gets dropped off the end. It gets taken from my array and gets put into the sorted side of the array. Now I got to call Heapify again, but it's already in order, so we're good to go. Now I'm going to swap the root with the highest index item, which is index 2, drop it off the end of my heap, which means moving off the end of the array into my sorted side of the array. Now I have just one element left, and that one element left will just go right over to the sorted side. Now notice this whole thing was done in place. In other words, I didn't have to create a new array and move everything around. I could just reassign the array's indices, and now I'm finished. You can learn more about the heap sort, the heap, and the priority queue in the priority queue chapter of the C++ data structures textbook.